Welcome to this explainer. Today, we're exploring how artificial intelligence is literally painting a dynamic, real-time picture of our world. We're going to focus specifically on geospatial AI, or GeoAI, and dive into its real-world applied uses. We're going to trace its impact all the way from the micro level, things like your daily commute or a smart wheelchair, right up to the macro level, where satellites are mapping out entire cities and coordinating global disaster responses. So, let's dive right in. We all rely on smartphone maps to navigate our daily lives, right? You punch in an address, you get a route, and you go. But rarely do we stop to think about the invisible intelligence working behind the scenes, predicting gridlock before we even back out of the driveway. It is a massively complex, applied use of AI that affects millions of us every single day, keeping our modern infrastructure actually moving. Get this. Predictive models from platforms like Google Maps have an ETA prediction accuracy of over 97%. Just think about how staggering that number is. To pull that off, the system isn't just looking at where cars are right now. It's blending live traffic conditions with absolute mountains of historical data. For instance, the AI knows that a specific stretch of freeway might cruise at 65 miles per hour at 6 a.m., but typically grinds down to a brutal 15 miles per hour by late afternoon. It merges that deep history with what is happening this very second. Section 1. Beating the traffic jam. AI on the road. Okay, so starting down at the micro level, literally right in the front seat of your car, how does AI actually predict the future? Well, routing systems use what are called graph neural networks. And these are incredible because they don't just look at one single isolated road. They analyze the massive interconnected web of the entire road network, understanding how a bottleneck on one random street is going to ripple out and cause a traffic jam 3 miles away. And it doesn't stop at just avoiding traffic. If the AI predicts heavy congestion, it automatically hunts for alternative routes by factoring in the incredibly fine details of the physical world. It's evaluating road size, the directness of the path, and vitally, the road quality. It actually knows whether a surface is paved, dirt, or covered in mud. This applied use ensures you aren't just taking the mathematically shortest path, but the safest and most practical one. Section 2. Empowering autonomous personal mobility. The AI wheelchair. Let's zoom in to indoor spaces for a minute. GeoAI can actually guide an autonomous wheelchair without needing any physical guiding lines taped to the floor. It all happens in 4 logical steps. First, a standard camera captures frames. Second, a framework called OpenVSLAM creates a virtual map from those images. Third, it generates an occupancy grid map, which is basically a safe versus unsafe floor plan. And finally, an A-star algorithm, a classic pathfinding tool, calculates the absolute optimal route. The whole software architecture just works in beautiful harmony. The framework takes that visual mapping data, combines it with a destination chosen on a simple Android app, and generates a fully guided route. The real beauty of this applied system is its flexibility. Think about it. Medical facilities or manufacturing warehouses don't need to do any expensive, crazy sensor renovations to support this kind of autonomous mobility. Now, what's genuinely brilliant here is how the occupancy grid map drastically simplifies the room's canvas for the AI. It takes complex 3D visual data and flattens it into a straightforward 2D grid. It marks areas as either blue, meaning obstacles are present, or green, meaning it's a safe open path. This lets the routing algorithm effortlessly draw a line from point A to point B right through those safe green zones. But hey, the real world isn't static, right? People walk around, chairs get moved. So to fill in those immediate, real-time details and make sure the wheelchair doesn't bump into a newly placed desk, a LiDAR sensor casts rays in a 90-degree arc right in front of it. This feeds instant distance data into a deep learning model. It acts as an active safety buffer, letting the chair dodge moving obstacles on the fly and then seamlessly return to its calculated safe path. Section 3. Extracting worlds from above, the macro zoom. All right, let's zoom way out and look at how satellites and AI are mapping entire cities. Extracting building footprints used to be incredibly labor-intensive, but today deep neural networks are stepping in, acting almost like automated digital artists. By using advanced networking models for both spatial features and geometric shapes, the AI can extract complex building footprints right out of messy, raw satellite imagery. This is absolutely foundational applied technology for modern urban planning, smart city construction, and digital mapmaking. And honestly, this is no small feat. The AI has to overcome vast visual diversity. Just think about how many different shapes, colors, and textures of roofs exist in a single city. This multi-layered deep learning process replaces all that manual mapping. and it regularizes noisy, pixelated building boundaries into clean, sharp vector polygons. Essentially, it turns them into mathematical shapes that scale perfectly. This is crucial because these clean shapes easily transfer over to Global Geographic Information System, or GIS platforms. It gives city planners clean, usable data instead of blurry pixels. Section 4. Securing our physical environments. AI, GIS, and remote sensing. Now, this macro-level mapping isn't just about figuring out where to zone a new neighborhood. It is actively applied to global security and rapid disaster management. By monitoring everything from illegal border crossings to real-time earthquake damage, AI is incredibly fast at spotting anomalies. If a flood or wildfire breaks out, remote sensing satellites capture the damage, GIS platforms map out the safe evacuation routes, and AI algorithms instantly analyze the data to predict exactly where the disaster will spread. It paints a predictive picture so we know exactly where rescue resources are most urgently needed. It's all about turning massive amounts of spatial data into immediate, actionable intelligence. Of course, applying this on a global scale comes with some major hurdles. Combining all these global sensors generates a massive amount of high-dimensional, complex data, and that creates critical challenges around data overload, system interoperability between different government and private formats, and the absolute necessity of ensuring accurate AI interpretation. Because think about it, an AI misinterpreting a shadow as a collapsed bridge during a disaster response, that could cost lives. That means these models have to be rigorously trained and constantly monitored. Section 5. The future of mapmaking, Gen AI in cartography. Finally, zooming back into the human element, we're seeing how generative AI, or Gen AI, is turning everyday users into master cartographers. Maps literally shape our entire understanding of reality, and today, models like ChatGPT and Gemini are completely democratizing map design. Gen AI is being utilized to automate aesthetic design, act as a critic to evaluate map quality, and, this is incredible, translate visual maps into audio descriptions for the visually impaired. It's opening up spatial understanding to people who traditionally could not access visual maps at all. AI is even teaching itself how to read maps using synthetic data pipelines. Researchers convert a map image into a structured pixel graph, sample random start and endpoints, and then use Dijkstra's algorithm, which is a classic mathematical shortcut, to find the absolute shortest route. Then, an AI path critic evaluates these automatically generated routes to ensure they make logical, human-like sense. It's essentially an AI checking another AI's homework to guarantee the map data is highly realistic and usable. So from anticipating a brutal traffic jam on your morning commute, to guiding an autonomous wheelchair safely through a crowded room, to coordinating disaster response from space, the canvas of our world is being repainted in real time by geospatial AI. These applied technologies aren't science fiction anymore. They are actively shaping our daily reality. Which leaves us with one final fascinating thought. Now that these incredible, powerful cartographers' tools are accessible to anyone, what kind of world will you map?